Welcome to this tutorial on Flux, the GitOps toolkit for Git-based Kubernetes cluster management. Flux is a powerful open-source tool that helps automate how we deploy and manage applications on Kubernetes clusters. Throughout this video, we'll explore what Flux is, how it works, and why it's become such an important tool in the Kubernetes ecosystem. This is part of our Kubernetes CI/CD series, where we dive deep into continuous integration and continuous deployment tools designed specifically for cloud-native environments. So what exactly is Flux? Flux is an open-source GitOps toolkit designed specifically for automating Kubernetes deployment and configuration management. The key principle here is that it uses Git as the single source of truth. This means all your application configurations, infrastructure definitions, and deployment specifications are stored in Git repositories. Flux is built around four core capabilities: continuous delivery, which means it automatically deploys changes to your cluster; declarative configuration, where you describe what you want rather than how to achieve it; automated reconciliation, where Flux continuously ensures your cluster matches what's defined in Git; and it's a CNCF graduated project, meaning it has been thoroughly vetted and is considered production-ready by the Cloud Native Computing Foundation. To understand Flux, we need to understand the GitOps principles it's built upon. First, Git as single source of truth means that Git repositories contain the complete and authoritative state of your system. Everything is versioned and tracked. Second, declarative infrastructure and applications means you define the desired end state of your system, not the steps to achieve it. You tell Flux what you want, not how to do it. Third, automated deployment and synchronization means once changes are committed to Git, they're automatically deployed without manual intervention. And fourth, continuous reconciliation and self-healing means Flux constantly monitors your cluster and automatically fixes any drift from the desired state defined in Git. If someone manually changes something in the cluster, Flux will detect it and correct it back to match Git. Flux architecture consists of three main layers that work together seamlessly. The first layer is source, which represents where your configuration comes from. This includes Git repositories, where your manifests are stored, Helm repositories containing packaged applications, and OCI registries for container images and artifacts. The second layer is control, where Flux controllers continuously monitor these sources and reconcile the state. These controllers are the brain of Flux, constantly comparing what exists in your cluster with what's defined in your sources. The third layer is deploy, where approved changes are applied to your Kubernetes cluster. This three-layer architecture ensures a clean separation of concerns: sourcing configuration, controlling changes, and deploying to production. Flux is composed of several specialized controllers that work together as a toolkit. The source controller is responsible for fetching artifacts from various sources, including Git repositories, Helm repositories, and OCI registries. It keeps track of changes and makes them available to other controllers. The Customize controller applies customized configurations to your clusters. Customize allows you to customize Kubernetes manifests without modifying the original files. The Helm controller manages Helm chart releases and upgrades. If you're using Helm to package your applications, this controller handles the entire lifecycle. Finally, the notification controller handles events and webhook notifications. It can send alerts when deployments succeed or fail, and it can receive webhooks from Git providers to trigger immediate reconciliation when code is pushed. Let's look at a practical example. This is a Git repository resource definition. It starts with the API version, source.toolkit.flux.io/v1, which tells Kubernetes this is a Flux source resource. The kind is Git repository, which specifies we're connecting to a Git repository. In the metadata, we give it a name, in this case, my -app. The spec section contains the configuration. The interval is set to 1 minute, meaning Flux will check this repository for changes every minute. The URL points to the GitHub repository location, and the ref section specifies which branch to monitor, in this case, the main branch. This resource tells Flux where to find your application configuration and how often to check for updates. Now let's examine the customization resource. This uses the API version, customize.toolkit.flux.io/v1, and has the kind customization. Again, we name it My Dash app in the metadata. The spec defines how to deploy the configuration. The interval is 5 minutes, meaning Flux will reconcile this resource every 5 minutes. The source ref section links this customization to the Git repository we defined earlier. It references a Git repository kind with the name My Dash app. The path field specifies which directory in the repository contains the manifests to deploy, in this case, /deploy. Finally, prune is set to true, which means if you delete a manifest from Git, Flux will automatically delete the corresponding resource from your cluster. This ensures your cluster stays perfectly synchronized with Git. The reconciliation loop is the heart of how Flux operates. It's a continuous cycle that keeps your cluster in sync with Git. Step 1. Flux pulls the latest changes from your Git repository. It's constantly watching for commits and updates. Step 2. Flux compares the desired state defined in Git with the actual state currently running in your cluster. It identifies any differences or drift. Step 3. If there are differences, Flux applies the necessary changes to bring the cluster back to the desired state. This could mean creating new resources, updating existing ones, or deleting resources that no longer exist in Git. Step 4. After applying changes, the loop repeats at the defined intervals. This continuous process ensures your cluster is always synchronized with your Git repository and provides self-healing capabilities if manual changes are made to the cluster. Flux provides several compelling benefits for managing Kubernetes clusters. First is audit trail. Because everything is stored in Git, you have a complete history of every change made to your infrastructure. You can see who changed what, when, and why, which is invaluable for compliance and troubleshooting. Second is automated sync. Flux continuously reconciles your cluster state without manual intervention. You simply commit to Git, and Flux handles the rest. Third is disaster recovery. If something goes wrong, you can easily roll back to a previous state by reverting commits in Git. Your entire cluster configuration is backed up in version control. Fourth is multi-cluster management. Flux can manage multiple Kubernetes clusters across different environments like development, staging, and production, all from centralized Git repositories. This makes it much easier to maintain consistency across environments. Let's recap the key takeaways from this tutorial. First, Flux enables GitOps workflow for Kubernetes by automating the deployment and synchronization of cluster resources based on Git repositories. Second, Git serves as the single source of truth for all your infrastructure and application configuration. Everything is versioned, tracked, and auditable. Third, Flux controllers automatically reconcile cluster state, continuously monitoring for changes and ensuring the actual state matches the desired state defined in Git. And fourth, it uses declarative configuration with automated deployment, meaning you describe what you want and Flux figures out how to achieve it. This approach makes Kubernetes management more reliable, auditable, and scalable. Thank you for watching this introduction to Flux. In future videos, we'll dive deeper into advanced Flux features and real-world implementation scenarios.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.